Thank you. The purpose of this talk is to give you an overview of our work in progress on the Java EE8 platform. So before I start, I need to make this disclaimer that this is an overview of work in progress. So what I'm going to be describing is not necessarily the final result. It's more a description of our goals and what we hope to accomplish. The final result will be determined through our expert groups under the Java community process. So I'd like to start with a brief overview of how we decided on the content and goals of this release of the platform. And then the focus of this talk will be on what we are planning. And then I'll conclude with some pointers as to how you can get involved. First of all, how did we decide on what to plan for Java EE8? What were our goals? We put quite a bit of background work into this. We started, as usual, looking around at what the current and emerging trends were in the industry and evaluating how to best target those that are most relevant to the platform. So some of these will be familiar to you from Java EE7, such as the focus on HTML5, work for support of cloud use. And then others are, like HTTP2, are new on the horizon. But with any platform release, we have additional goals as well. We're continuing our focus on ease of development. And then we also want to provide compatibility with previous releases to protect the investments that our customers make in the platform. We spent a lot of time gathering feedback from the community. This takes many forms. What we heard on our users lists, our mailing list for our projects, bugs submitted to our issue trackers, feature requests, what our evangelists hear as they travel around the world, reaching out to developers like you. And we consolidated this into a survey to the community. The survey was quite large. It had 3 parts, dozens of questions. We got many, many responses, thousands of comments. There were over 4,000 participants in this survey. The third part of the survey, we asked our participants to prioritize among those features that were found to be the most popular ones in the earlier phases of the study. And the URL that I've given you here is to the summary that I wrote of the results that we got from this, this survey. This chart shows you the results of the prioritization. If you read it clockwise from the top, you can see that an API for JSON binding was the most popular of the features that we proposed. Security improvements were very popular, interceptors for authorization, simplification of security. People would like to see us bring the JCache API into the platform. And also a new MVC framework was very popular. So, as usual, when we look at these results, we can identify themes for this release. Some of these are continuation from our Java EE7 work. In fact, I think most of them are. Focus on HTML5 and enhancements for the web tier. Continuing our theme of ease of development and CDI alignment. And then improvements for infrastructure, for running in the cloud, but not just in the cloud, also for on-premise. So I'd like to start with a description of some of the work that we're proposing to do in the web tier. Let's start with JSON binding, which was the most popular result in our survey. What this is it's an API to marshal between Java objects and JSON text. So you can think of this as similar to JAX-B in the XML world, or similar to JPA in the object relational mapping world. What we'd like to do is similar in the sense that we want to provide annotations to customize mappings between these objects and JSON, to provide convenient defaults for this mapping transformation. And then there are a number of existing JSON binding implementations out there. We'd like to draw from the best practices of those in developing this API. Moxie is our own, Oracle's own implementation. It's available through the Eclipse Link project. I believe that Jackson is otherwise the most popular of these implementations, but we'd also like to provide pluggability contracts so that you can choose your JSON binding provider and plug that in. So here's an example. We have a Java class. I've annotated this as an entity because we'd like this to work all the way from entities on up through the web tier. And what I'm doing is I'm creating an instance of this entity. I'm creating a Duke. Duke has a name, a gender, and a set of phones. And then from Duke, I'm going to marshal Duke into JSON. And again, keep in mind that we're still fairly early in our process, so I can't promise that this API will look absolutely identical when we're done. But we're marshaling Duke, and we should get a result that looks something like this in JSON. So the goal here is to provide for mappings that will work all the way from the client to the database and back. So you can imagine starting with JPA entities in your database, pulling those entities into POJOs in the JAX-RS runtime, and then mapping those out to JSON text in the web tier. And notice that this also, JAX-RS is an extremely important technology in the middle here. Notice that this also gives JAX-RS a standard way of supporting the application JSON media type in a way that's very convenient for developers. So underlying this JSON binding work is work that we've begun in Java EE 7 with a JSON processing API. So JSON-B builds on top of this JSON-P. And what JSON-P is an API for parsing and generating JSON text. It's at a lower level. We also want to keep this JSON processing API up to date. And there are a number of new standards in this area that we want to track. This involves adding editing operations to JSON object and JSON array. And then we also want to add some classes and methods to leverage Java SE's work with lambdas and stream operations. So the first of these new standards is JSON pointer. And it's just what its name implies. It's a string syntax for pointing into a JSON document, for referencing a value in a JSON document. So if we build up, using the JSON-P APIs, we want to build up a document. So our document will be an array consisting of two people, Duke and Jane. So it will look something like this. And then we create a pointer. This pointer references the first element in this array, pointing to phones, and in particular, a mobile phone. Or I should correct myself and say that this is a pointer that is not yet pointing into the array until we ask the pointer for the value for this particular JSON document, for our contact information document. So when we do this call, the pointer get value, we receive a pointer to Duke's mobile phone. There's another new standard called JSON patch. And what a patch is it's itself a JSON document. The document consists of an array of objects that are operations for modifying a JSON document, such as adding or replacing or removing. This is the full set of operations. So each operation has an op field, which is the operation, and it has a path field, which tells you what you're operating on. And then depending on the operation, it may have additional values as well. Like if you're doing a replace, you need the new value. So looking at this JSON document on the left here, it consists of two operations, a replace and a remove operation. And on the right, we have our contact information with Duke and Jane again. So as we step through this, we're executing these operations in sequence. So an operation can affect the result of a subsequent operation. So here we're replacing Duke's phone. We've replaced it with a new value. And then we're going to remove the second element of the array. So Jane is now gone. OK, but JSON object and JSON array are currently immutable. So we need some form of editing capability to implement JSON patch. Our spec lead initially proposed using a builder pattern, creating temporary objects for editing and then converting them back. Some people in the expert group had other ideas that are perhaps better. So we're still in the process of working this one out. Another aspect is leveraging what Java SE8 has to offer. So a JSON object is itself a map, and a JSON array is a list. It seems natural that we should be able to query over these using the lambdas that were introduced in Java SE8. So this example takes the contacts that we just saw. It's filtering over those that are female, and then it's extracting their names as a list of strings. But notice, with this list of strings, we've now left the JSON world. So what we want to do is add new collectors, augment the JSON processing API to add collectors to return values that are still usable for further operations in JSON. So we like collectors, as shown here, for collecting to a JSON array or collecting to a JSON object. And then we can issue further operations over these. OK, another new technology that's part of the HTML5 standard is support for server-sent events. And what these are is for server-to-client streaming of textual data with a particular MIME type. Text event stream. And the way this works is the client opens a connection that's a long-lived HTTP connection. The server uses this connection to push notifications to the client. So you can think of this as a kind of publish-subscribe capability. We evaluated several possibilities for homes for this technology. The Servlet API, WebSocket, JAX-RS, maybe something custom, standalone. We had our own ideas, but we asked the expert groups, and they concluded that JAX-RS was the best fit here. And this coincided with our own view. JAX-RS already supports streaming of HTTP resources. This is a relatively small extension to the JAX-RS spec. And conveniently, our reference implementation for JAX-RS, Jersey, already supports server-sent events. Now, again, I'm not promising that the end result is going to look like what Jersey does, but this is one data point for work in the expert group. So to give you an example, we want to have a stock ticker that's going to push stock notifications to the client. So notice that we've annotated the method here, getQuotes, as produces text event stream. That's the MIME type for server-sent events in HTML5. We're creating an event output, which is going to be the way this data is going to be passed back. And we're starting a thread that's going to produce these notifications. So the key part here is on the right side of this slide, where our run method is producing the new stock quotes and then sending them out using this event output object. So we're going to loop until this process is terminated, which will happen when the client closes the connection. Now, as part of our Java EE7 work, we provided a client API for JAX-RS. We'd also like to provide a client API for its server-sent events. Now, your client doesn't have to be a JAX-RS client. It could, of course, just be a plain old JavaScript client. But we want to be complete, and we want to provide a JAX-RS client as well. So here, the client is creating a target to our stock ticker URL and creating an event source, which has an onEvent method to receive the events that are being sent by the server. And then when one of these events comes in, the client is extracting the data that corresponds to the stock quote. Now, the key thing here is at the bottom of the slide, where opening the connection is what kicks off the entire process. Another web tier technology that our survey revealed to be quite important to the community was support for action-based MVC. So we currently have a component-based MVC framework in the form of JSF. So in a component-based MVC framework, it's the framework itself that is serving as the controller for the model view controller. With action-based MVC, it's the application that's going to be providing the controller logic. So this new MVC work is designed to complement JSF. It's a different style, and it completes what we have in terms of MVC architectures. So the idea here is to glue together key Java EE technologies. For the model, obviously CDI managed beans, together with support from bean validation or JPA at the database level. For the view, our technologies of facelets and JSPs. And then the controller will be JAX-RS through JAX-RS resource methods. I've stolen this example from the MVC spec. The early draft of the MVC spec is now available for downloads, so you can see the work in progress with this new expert group. So here we have a JAX-RS resource class, and notice that we've annotated the controller method with the controller annotation. So this method is going to be providing our controller logic. So I want to look at the pieces now. Here's the model. The model is a CDI bean. It's a named bean. It's got a name so that we can refer to it in our JSP pages. So this is very simple. It's just giving you the ability to get and set a greeting message. This is our controller again. So notice that we're injecting this bean into our controller. And our hello method, the controller logic, is setting the value of the message to hello there. And it's returning a reference to the JSP page that's going to be the view. Here's the JSP page. It's very simple. But notice that down here towards the bottom is the reference to greeting.message. So in other words, to that named CDI managed bean that now has the updated message. So when this view is displayed, it will show hi there. Another important emerging standard, actually it's just newly a proposed standard, is HTTP2. This is a major improvement to the HTTP 1.1 protocol. The HTTP 1.1 protocol goes back to 1999, so it's fairly old. But the goal here is to offer performance improvements without the need for workarounds, such as you find today. So reducing latency, addressing the head-of-line blocking problem, supporting parallelism without requiring multiple connections, which is a standard workaround today, which is not particularly good. But at the same time, retaining all of the user visible semantics of HTTP 1.1. So the way this works is by multiplexing over a single bidirectional connection, where the requests and the responses correspond to streams over this connection. The streams themselves are broken down into frames, so you can have multiple frames from multiple streams interleaved over a single connection. And the binary framing layer gives you a description of the frame, what its length is, what stream it belongs to. It can also have information about prioritization. So why prioritization is good is because you may want to prioritize what data gets delivered to the client first. So if you're displaying a web page, you'd like to have your client receive the CSS that describes that web page before they receive the data that the CSS is going to format. So stream prioritization gives you a mechanism for doing that. Server push is a way for the server to push out data in anticipation of what the client will need. So it gives you a way of providing further optimization. So it'll be the task of the Servlet 4.0 expert group to figure out how to leverage HTTP2 through the Servlet API. So this provides server-side support for HTTP2. The SE folks are working on the client-side support for HTTP2. So requests and responses, as I said, will be multiplexed. We'd like to add APIs so that stream prioritization can be specified, and also so that server push can be specified in your application. Okay, I'd like to shift over now to our second theme for this release, which is continuing our work on ease of development and alignment or leveraging of CDI. And I'm going to be talking about security interceptors and simplified messaging, but I also want to note that there are other areas that we're working on as well. In particular, injection alignment for JAX-RS. There's a little bit of work that needs to be done there. And defining a scope, a CDI scope for WebSocket endpoints. Another area of simplification, which might be controversial, but it's always good to ask questions, is whether we should do any kind of pruning of the old EJB-style client view and the requirements for the support of IAOP interoperability that go with that. So CDI provides a great ease-of-use facility for Java EE applications. And in Java EE 7, we leverage the interceptor mechanisms that CDI provides to provide what are effectively container-managed transactions for all managed beans, taking this idea that comes from the EJB world, but making it more generally available through CDI transactional interceptors. In this release, we'd like to do something similar in the area of security authorization. Right now, we have declarative security in terms of what you can specify with roles allowed, for example, in EJB or in the servlet spec. But we'd like to do something that's more general and flexible. So this gives you some idea of what we'd like to achieve. So we're assuming an interceptor mechanism that is used here. And notice that with each of these examples, with the first two examples, I specified the role that's required for the successful invocation of the methods here. But notice also, in the first, I want to access contextual information. So I want some information. I want to know that the office hours are appropriate for the invocation of this method. So this is contextual information that's available through CDI context. In the second one, I want to know that the caller has the property that its direct reports include the employee whose salary information is going to be accessed. And in the third example, I want to access a repository of rules and check that the caller has rights to the report rule. So this is very flexible. It's leveraging CDI, and we're embedding the use of an expression language in these interceptor invocations. In Java EE 7, we did a considerable simplification of the JMS APIs in JMS 2.0. But we didn't touch message-driven beans, which haven't really been improved very much since they were introduced in EJB quite a while ago. What we'd like to do in JMS 2.1 is to provide an alternative to these message-driven beans that lets JMS messages be delivered asynchronously to other managed bean types, for example, CDI managed beans, in a more general way and in a simpler way, without the need for message listener implementation, for example. So if we look at JMS message-driven beans today, there's a lot of metadata that you need to supply for your message-driven bean. And the annotations to do so, I have to say, are kind of annoying. So, and your bean class has to implement a message listener interface, which tells you what you need to call your method. And this method only takes one argument, which is your message. And it's kind of an old-style API design. What we're proposing for JMS 2.1 is that any Java EE managed bean should be available to be a listener. In this case, we have a CDI managed bean. I've annotated it request scoped, but you could imagine that it is application scoped as well, or it could be singleton. And the relevant annotation here is this JMS listener annotation. And the only piece of information we're providing is the queue from which the messages are going to be delivered. So I've annotated the method myCallback. You can call it anything. I've applied a transactional interceptor to it, which you can do. And it takes as its argument the incoming message. Now, because we're using CDI here, I could have other arguments to this method as well. I could pass in contextual information with arguments that are injected using CDI injection to give you even more flexibility. So this is a lot simpler and a lot more convenient than what we have with message-driven beans. In our survey, we also asked about pruning, and what I mean by that is allowing vendors to optionally implement parts of our specifications. In the last release, we pruned JAX RPC, JAX-R, old-style entity beans, and the old deployment API. We asked in our survey whether we should take the first step here with regard to EJB, old-style interfaces, and support for IAOP interoperability. And this first phase means defining something as proposed optional. So it's not yet optional. it's saying that the next Java EE expert group, Java EE 9, would have the option of considering whether this technology should actually be made optional. And making a technology optional doesn't mean that it's forever gone, because your vendor can still implement it. And if they do implement it, they have to implement it compatibly with our existing rules. And of course, Glassfish will implement it as the reference implementation. So, oops, I want to go back here. So this is what things look like as of EJB 2.0 in the client view. You have a home interface and a remote interface. They throw checked exceptions. You need this pair. In EJB 3.0, we made this unnecessary. Your interface can just be a simple business interface. So this was work that we did in 2006, so quite a while ago. So we're asking the community whether or not it is time to make optional or proposed optional this old style client view. So the third theme that I'd like to talk about is what I've called here modernizing the infrastructure, both for use in the cloud, where it's particularly important, but also for use on-premise. And the two areas that we are looking at here in particular are the management API and work in Java EE security. So these are both new projects under the Java community process. We had many, many suggestions in the security area. I'm going to talk about a few of these, but there's much too much here that I can go into all of them. So Management 2.0 is intended as an update to the old J2EE management API. And the fact that it's called J2EE rather than Java EE lets you know how old this is. We asked people what we should do in terms of how do we modernize it. And the vast majority of the responses that we got said that we should provide REST-based interfaces to augment the current management EJB APIs that we have today. The idea is that we would provide equivalent functionality, perhaps even more functionality, but with REST-based APIs, which are indeed more appropriate for use in cloud environments. And our spec lead would also like to address the issue of providing simple deployment interfaces. We don't want a replacement for the entire old deployment API, but we'd like to do something simple that's highly usable in the area of deployment. So there's a lot that we could do in security. You know, we've gotten much feedback that our existing security APIs are too complex, they're confusing, they're out of date, they're not really as portable as they should be. There's a lot of reliance on vendor-specific features. And you know, we've heard loud and clear that applications need more flexibility. So I'd like to look at a few of the improvements that we're contemplating here. The first of these, password aliasing. We started this work in Java EE 7 in the platform group, but we didn't have time to complete it. So we actually backed this out, but our plans are to revisit it in this release. The idea here is that you should never have a password in clear text in your code, in your metadata, in your deployment descriptors. But instead of having your password in clear text, you can define a password alias. And the alias maps to the password bundled together in a secure credentials archive, so that at runtime, the container can resolve the alias you're using to the actual password in a secure way. And the credentials archive can be bundled together with the application. So in this little example, I've shown our syntax for password aliases. This is what we had proposed to the Java EE7 expert group. It's not yet clear whether this work will be done by the security expert group or the platform expert group, but we will, our intention is to address it one way or the other. Another important suggestion that we received for security, and this was received as a JIRA issue that was filed, is for user management, to allow the application to manage its own users and groups. And this avoids the need to access the server configuration, which is, again, an important feature when you contemplate running in the cloud. So the user information would be stored in an application-specified repository, such as an LDAP repository or a database, or perhaps even a file, or some custom repository. And then accessing this, corresponding to this repository, is a user service that allows you to manipulate the information from the user repository. So this looks similar to, this is modeled, I should say, after work we did with data source definition, where you're defining the application's need on a particular data source that needs to be available in the environment. Here the application is defining its reliance on a particular user source repository that is going to be provided in the environment. And then corresponding to this repository is the user service for allowing you to create and delete users or create and delete groups and perform your mappings between users and groups. So here's a straw man example of what this might look like. This is an example for an LDAP user repository. The name is the Jindy name where you're going to access this. The URL is the URL for the repository itself. And I've provided a user, and notice that the password is using our password aliasing capability. So what we're going to do here in this authenticator class is to inject a resource, a reference to this resource. We're going to look up this repository and make it available as a user service. And then at runtime, we can access the user service, for example, to load the information for this particular user and see if the user is enabled for the task at hand. So we'd like to take a similar approach for role mapping. Many vendors offer defaults in this area. Our approach here is basically the same as what I just characterized for the user service. We'd like to standardize a role service where roles can be stored in application-specified repositories, and the application can assign roles to users and groups based on some application-specific model. Again, without the need to access the server configuration. So similar to our user service definition, we have here a role mapper definition where the repository can again be a data source or LDAP or memory file custom. And our role service allows us to grant and revoke roles or to get roles for a user and group. So we're proceeding similarly here. We're injecting the reference to the role service that corresponds to this repository. And then we can query this role service to get the roles for a particular user. Okay, so where are we today? We have 11 JSRs and expert groups that will be part of this release, and they're all up and running. Some of them for longer than others. I think CDI 2.0 was the first of these. More recently, our management, JSON processing, and security expert groups were recently formed. These are the major focus areas for this release. In addition, we expect that we will be doing a number of smaller JSRs, basically driven by the needs of the platform and the need to update some of our technologies, or maintenance releases, which are to small improvements to bring a technology up to date. These are the ones that we anticipate that we might be doing. All of these are Oracle JSRs, except for Bean validation, which is being done by Red Hat, and Batch, which of course comes from IBM. So I want to stress our commitment to a transparent process. All of our Java EE8 JSRs are run in the open on all of the Oracle ones on java.net. And the first URL here is that for the platform expert group. The second URL gives you a table that has links to all of the others. So if you want to find the project for a particular expert group, you can do so from this one source. So each JSR, each expert group has its own project. We tried to get the names to line up, but that isn't always the case. When you access these projects, you can view all of the expert group emails. You can subscribe to an observer list, we call them the users list, which will deliver to you copies of all of the emails that were sent by the expert group. And in addition, you can use the users list to engage in discussions with other users and also with experts who are all supposed to join the users list as well. So you can use this to get interesting discussions and provide feedback. You can also provide feedback, and we've gotten many interesting suggestions through the issue trackers that are linked from these projects. We use Jira issue trackers, so you can submit bug reports, or you can submit feature requests through these issue trackers. And each project also has a download area that's publicly accessible, where you can download documents that are produced by the expert group, such as specification documents that are work in progress. So to get actively involved, there are a number of paths. One that I'd like to encourage is the Adopt a JSR program. So there are many JUGs that have formed Adopt a JSR projects. The idea is for JUG members to get together, choose JSRs to focus on, hold discussions as to how they can best track the JSR and provide input into the expert group. So we really welcome this process. You can also sign up on the users list to join a particular project and get feedback that way. The Aquarium is the site that we use to post updates on work in progress. So our evangelists write blogs for the Aquarium that will give you up-to-date information on new features that are being added to JSRs. And these are really very good and informative. So if you're not tracking the Aquarium, I would urge you to do that. And then, of course, all of this work will be done in our reference implementation. It's still pretty early to be implementing very much, but the reference implementation, which of course will be Glassfish. So I will leave you with that, and I'd like to thank you very much for coming to this talk. Thank you.